Let's start with a discussion of distributions, and we'll start with the most common, using a coin. When a coin is flipped, it has a probability of landing heads up and a probability of landing tails up. If we flip a coin many times, we collect a number of measurements of the heads and tails that landed face up, and intuitively we know that the number of times we get a heads up will be equal to about the number of times we get a tails up for a fair coin. If you flipped a coin 100 times and you received heads each time, you'd probably doubt the fairness of that coin. We can consider the result of each flip of this coin as a random variable. When we can consider the set of all possible random variables together, we call this a distribution. In this case, the distribution is called binomial, since there's two possible outputs, a heads or a tails. It's also an example of a discrete distribution, since there are only categories being used, a heads and a tails, and not real numbers. NumPy actually has some distributions built into it, allowing us to make random flips of a coin with given parameters. Let's give it a try. Here we ask for a number from the NumPy binomial distribution. We have two parameters to pass in. The first is the number of times we want it to run. The second is the chance we get a 0, which we will use to represent heads here. Let's run one round of this simulation. Great, so if you're following along in a Jupyter notebook, you either got a 0 or a 1, and half of you got a value that agreed with the one that I got. What if we ran the simulation 1,000 times and divided the result by 1,000? Well, you see a number pretty close to 0.5, which means half of the time we had a heads and half of the time we had a tails. Of course, an even-weighted binomial distribution is only one simple example. We can also have unevenly weighted binomial distributions. For instance, what's the chance that there will be a tornado today while I'm filming? It's pretty low, even though we do get tornadoes here, so maybe there's 1/100th of a percentage chance. We can put this into a binomial distribution as a weighting in NumPy. If we run this 100,000 times, we see there are pretty minimal tornado events. So you might be wondering why I'm talking about such a simple and intuitive distribution. I mean, we all understand flipping a coin from when we had to make important decisions as children. But what I want to demonstrate is that the computational tools are starting to allow us to simulate the world, which helps us answer questions. I could have shown you the math behind this, and we could have worked out the probabilities. But a simulation is essentially another form of inquiry. Let's take one more example. Let's say the chance of a tornado here in Ann Arbor on any given day is 1%, regardless of that time of year. That's higher than realistic, but it makes for a quicker demo. And let's say if there's a tornado, I'm going to get away from the windows and hide, then come back and do my recording the next day. So what's the chance of this happening 2 days in a row? Well, we can use the binomial distribution in NumPy to simulate this. Here we create an empty list, and we create a number of potential tornado events by asking the NumPy binomial function using our chance of tornado. We'll do this 1,000,000 times, which is just shy of 3,000 years worth of events. This process is called sampling the distribution. Now we can write a little loop to go through the list and look for any two adjacent pairs of ones, which means that there were 2 days that back-to-back tornadoes. We see that this ends up being roughly 100 2-day tornado events over the 3,000 years, which frankly is still too many for me. My point here, though, is that modern computational power allows us to very quickly simulate the effects of different parameters in a distribution, leading to a new way of understanding the problem. You don't have to work out all of the math. You can quite often simulate the problem instead and observe the results. In the next lecture, we'll talk a little bit more about distributions.